So let's take a look at another geometric sequence. This time, we'll take a look at our first, second, third, fourth, and fifth entry. And I've got it represented here with these sets of boxes. So for our first one, that's easy to count. We've got 3. Our second one is 9. Our third one, getting a little bigger. Trust me, it's 27. Fourth, if you want to count them all, or if you want to do a little area, length times width, I can tell you it is going to be 81 boxes. And then our last one, a little more difficult to count, but I can tell you it is 243 boxes. So, how is our geometric sequence changing? Remember, we're going to be multiplying to find our change. So to get from 3 to 9, we're multiplying times 3. To get from 9 to 27, we're again multiplying times 3. So here we've got a constant multiplication times 3. On the other side, we've still got a change of plus 1 each time. And what I want to look at now is, just like we did in our arithmetic sequence, we have to go back to our 0th entry. Now, for our arithmetic sequence, we did the opposite, or the inverse operation for the change, the pattern. So we're going to do the same thing here. So instead of, because we have to get from that 0th by multiplying times 3, we're going to divide by 3. So we end up with 1. And you can check my answer here by saying, okay, 1 times 3 better give me 3. And it does. So our 0th entry would be 1. So I can even draw that here. Here's our 0th entry. So now we want to write a formula for this sequence. So basically, every time we are multiplying by 3, and we are multiplying that number 3 times itself, the number of times of our entry. So for example, here, for the first entry, we've got 3 times itself 1 time. For the second entry, we've got 3 times itself 2 times. For the third entry, we've got 3 times itself 3 times. And that's what I mean when I say geometric sequences are exponential. They have exponents in their formulas. So basically, if we wanted to say, if we wanted to do this, whoops, I somehow got to eraser here. If we wanted to go from our x value here, our entry value, to some y value, what we would have to say is y equals 3 to the x power. And then in this case, we're just taking the 0th number and multiplying it times the 0th number, which happens to be 1. So we just get the same answer. But sometimes the 0th entry is not 1. Sometimes it's something different. So we also need to multiply by the 0th entry. So here, written down here, I have the general formula for a geometric sequence. So we're going to take the ratio, in other words, what number are we multiplying by each time, to the x power, and then multiply by the 0th entry. And that will be your general formula for every exponential geometric sequence.